Alright, in this video we're going to be looking at how to integrate polynomials. If I have an integral of ax to the power of n, the rule is the following. To integrate this, you add 1 to the power, and then you divide it by the new power, which in this case will be n plus 1. So it becomes ax to the power of n plus 1, add 1 to the power, divide by the new power, and you must always do plus c, plus the constant of integration. So let us now look at a few examples. This is our first example. Integrate half x cubed. So the first thing we do is we add 1 to the power, so a half x to the power of 4, and then we divide all of this by the new power, which is divided by 4. So then this just becomes half x squared, half x to the power of 4 over 4, which is just divided by 8, and then we can do plus c. Now let's have a look at our next example, which will be the following. Pause the video and give this a go first. Well, to integrate this, we add 1 to the power, so 3x to the power of 2 plus 1, which becomes 3, and then we divide it by the new power, which is divided by 3, minus, you can do minus 2, this is the same as x to the power of 0, so you can add 1 to the power, which becomes 2x to the power of 1, divided by the new power, which is divided by 1, plus c. So now to simplify this, we can see that the 3 and 3 will cancel, and the divide by 1 isn't really necessary. So all we have is x cubed minus 2x plus c, and that is your integral for this question here. Okay, this is our next question here. Integral of 4 on 5 x cubed minus 2x squared dx. First thing we do is add 1 to the power. So that becomes 4 over 5 x to the power of 4, and then we divide it by the new power, which is divided by 4. Then we do the same thing with the minus 2x squared. Minus 2x squared, we add 1 to the power, so it becomes minus 2x cubed, and then we just divide by the new power. And then we have to do plus c as always. Now that we have this, we can just simplify the right-hand side of our equation, and what we get is 4 over 5 x to the power of 4 divided by 4. We can see that the 4 and the 4 can cancel. So then what we have is x to the power of 4 divided by 5, minus 2x cubed divided by 3, plus c. And that is our integral for this question here. Okay, this is our next question. The integral of x times x plus 1 on x. First thing we're going to do is we're going to expand the brackets out. So in this case, we get the integral of x squared plus 1 dx. And this is just doing x times x and x times 1 over x. And then what we can do is the simple integral rules that we did before. Add 1 to the power. This gives us x to the power of 3. Divide by the new power, which is divided by 3. And then do the same with the x, with the 1. So this is the same as 1 times x to the power of 0. So add 1 to the power, you get x to the power of 1. So plus x to the power of 1. Divided by the new power, which is just 1. And then you can do plus c. But this part here is really just the same as just x, so I'm not going to write the whole thing out. And that is our integral for this question here. Okay, this is our next question. The integral of 2z squared times z take 1. So we're going to do the same thing. We're going to expand out the brackets. So in this case, we'll have the integral of 2z cubed minus 2z squared dz. And now let us work out the indefinite integral for this one here. So first thing we do is we add 1 to the power, in which case we get 2z to the power of 4, but then we divide by the new power, divide by 4, minus, add 1 to the power. This becomes 2z to the power of 3, and we divide it by 3, plus c. And we can simplify this. We can cancel the 2 and the 4 to get 2. So what we end up having as our final answer is really just z to the power of 4 divided by 2, minus 2z to the power of 3 over 3, plus c. That is our integral. Okay, this is our next question. The integral of t take 1 cubed. Let us work this out. First thing we're going to do is expand this out, and I'm going to easily expand it out using Pascal's triangle. So this is going to be the same as 1 times t cubed minus 3t squared plus 3t minus 1 dt. So now let us integrate this out. This is the same as add 1 to the power for this one here. That gives us t to the power of 4 divided by the new power. Then you add 1 to the power for 3t squared. You get minus 3t cubed over 3. Add 1 to the power for this one here for 3t. Then we get plus 3t squared all over 2. And then integrating a constant, you can simply just add x to it. So in this case, the integral of minus 1 is just minus x plus c. Now let's simplify. The only thing we can simplify here is the 3 divided by 3. And that just gives us t to the power of 4 over 4 minus t cubed plus 3t squared over 2 minus x plus c. That is this integral over here. Okay, this is our next question over here. We're given that the derivative of a function is 2x take 1, and we have coordinates on the original function. Our goal is to find what y is in terms of x. So the first thing we're going to do for this question is simply just find the integral of dy on dx. So when we do that, what we end up with is that y is simply equal to the integral of 2x take 1 dx. So let us work out this integral now. To work out this integral, we add 1 to the power, divide by the new power. So when we do this, we do to the power of 2, divide by 2. 2 and 2 cancel, so it's really just x squared. And the integral of minus 1 is just minus x plus c. But to actually solve this question, we need to work out what the value of c is. So we're going to substitute in the value coordinates of y equals 0 and x equals 1 to solve for c. So 0 is the same as 1 squared minus 1 plus c. That would be the same as saying c is equal to 0, in which case we can simply just say that all of this is just plus 0, or in other words, this is just the final answer. This is the equation of y in terms of x. Okay, this is our next question. Okay, well, again, our goal here is to work out the equation for y in terms of x, and the first thing we're going to do is just integrate to find what y is. So when we integrate what y is, okay, we get the integral of 3 minus x squared dx. Okay, and when we integrate this, we know that the integral of 3 is just going to be 3x. And the integral of minus x squared, add 1 to the power, divided by the new power. So in this case, it's x cubed, divided by 3, plus c. So now that we have that this is our integral, we still need to work out what the value of c is. And we're going to work out the value of c by just subbing in these coordinates into our equation. So we know that 3 is going to be the same as 3 times, y is equal to 2. So 2 is the same as 3 times 3 minus 3 cubed on 3 plus c. So when we work this out, we get that 2 is really the same as 9 minus 27 divided by 3, which is just 9, plus c. So the 9 and 9's cancel. So what we're really left with is that c is equal to 2. Okay, so c is equal to 2. And so I'm just going to replace the c over here with 2. And this is our final answer. This is the integral of this question here. Okay, and this is the next one. Find an equation for y in terms of x for this function over here. So first thing we're going to do is just integrate both sides. So y is simply equal to the integral of 2x to the power of 4 plus x dx. And we're going to do the same integral steps as we did before. Add 1 to the power, divide by the new power. That will give us 2x to the power of 5 on 5. Plus, add 1 to the power, so x to the power of 1 plus 1 divided by 2. So that's x squared on 2 plus c. So now that we have this, we can clean it up and we can work out what the value of c actually is. We can work out c by just substituting in our coordinates 0, 0. And we must always substitute it in. Do not always fall under the impression that if it's 0, 0, c is simply going to be 0. That is not always true. So let us check it here first. Okay, in this case, we can see that all of this is just equal to 0. And all of this is simply just equal to 0 as well. So in this case, c does in fact equal to 0. Okay, so we can get rid of that entire calculation. And this would be our final answer. But always check, okay? Just because the coordinates are 0, 0 does not mean c necessarily has to be 0. Okay, this is our next question over here. We are given a derivative with volume with respect to time is given by this equation here. And they've also told us for a specific coordinate point, there exists when t, v, okay, when x value is t, y value is v, we're given that 3, 9 is a coordinate system. So we need to first work out what is the equation for a volume function where the input is going to be time. So we have the derivative of volume with respect to time. We need to go backwards. So rather than differentiating, we're going to integrate. So for this question here, let us integrate. Okay, it is simply going to be the integral of t squared minus 1 dt. And now that we have this is really going to be the same as t cubed divided by 3 minus t plus c. And the reason we got that is because we add 1 to the power divided by the new power, we get this. And then the integral of 1 minus 1 is just going to be minus t. And now we need to work out plus c. So we're going to work out plus c by simply substituting 3, 9 into our equation. So when the volume equals 9, we know t equals 3. So 3 cubed over 3 minus 3 plus c. This here is the same as 27 divided by 3, which is 9. So 9 equals to 9 minus 3 plus c. 9 and 9 cancel, or in fact we can do it this way. We can say 9 minus 3 is 6. Okay, and then if this is 6, then to get rid of the 6, we can minus 6 from both sides. And then we get that 3 is equal to c. Okay, so c is equal to 3. So that means we can replace this c over here with a 3. And that is our equation of the volume with respect to time. Now we need to work out what is the volume when the time is equal to 0. Well, when the time is equal to 10. So all we're going to do is substitute 10 into our equation. So what we get is 10 cubed divided by 3 minus 10 plus 3. And we know that this here simply forms minus 7. And then 10 cubed divided by 3 is the same as 1,000 divided by 3 minus 7. And if we wanted to simplify this even more, you can make it minus 21 over 3, which is really just the same as 979 divided by 3. And this would look like the closest we can get to an answer. So this is your final answer here. Okay, this is our next question. We are given that the derivative function for a question is equal to this, where a is some unknown integer. And we also know that when x equals 1, the derivative is equal to 3, and the y value of the original function is equal to 3. And we're told to work out what is the y value of the function, not the derivative, the y value of the initial function, when x equals to 2. So the first thing I'm going to do is work out what the value of a here is. To work out the value of a, we already know that when x equals to 1, the derivative is equal to 3. So let us now substitute in that information. So dy on dx equals to 3, and a times when x equals to 1 whole squared plus 1. So 3 is equal to a plus 1, in which case a is simply equal to 2. So we've just worked out that the derivative is equal to 2x squared plus 1. Okay, so that's by using these two pieces of information here. Now let's work out an equation for y in terms of x. Okay, so y in terms of x is really just the same as the integral of 2x squared plus 1 with respect to x. Okay, so now that we have this, that a is equal to 2, we can now integrate this to get 2x cubed divided by 3, and we did that by adding 1 to the power and dividing by the new power. And then the integral of plus 1 is really just the same as plus x. Now we do plus c as well. So now that we have this, let us now work out the value of c. To work out the value of c, we know that when x equals 1, y equals to 3. So that means y, right, when it's equal to 3, 3 is equal to 2 times 1 whole cubed divided by 3 plus 1 plus c. And to solve this equation for c, we know that this is really just the same as 2 divided by 3. So we can say that 3 minus 1 minus 2 over 3 is the same as c. So that means 2 minus 2 over 3 equals c. And to solve this, this is really just the same as 6 over 3. So your final answer is c equals to 4 over 3. Okay, so now that we have c equals 4 over 3, we now have that the original equation for y is really just the same. As 2 over 3x cubed. 2 over 3x cubed plus x. And we know that the value of c is 4 over 3. So we're going to write plus 4 over 3 like this. But we haven't answered the question yet. We still need to work out what the value of y of 2 is. So to work out y of 2, let's substitute x equals to 2. So 2 times 2 cubed divided by 3 plus 2 plus 4 over 3. 2 times 2 cubed is 16 divided by 3 plus 2 plus 4 over 3. And another way of writing 2 as a denominator of 3, as a fraction where the denominator is 3, I should say, is plus 6 over 3. Okay, so 6 plus 4 is 10, plus 16 is 26. So your final answer is 26 over 3. That is the answer to this question over here.